If it hasn't happened for you yet, don't worry, it will. Subnetting is about to get fun. By the time we're done here, we will learn how to break Class B networks into multiple subnetworks based on specific requirements. And once again, I'm going to throw out there, this is not your first rodeo into the world of IP addressing. There is some prerequisites before you get there. It's the same prerequisites as we had before, but I've added one to it, and that is you know how to subnet Class C addresses, which was literally the last video in this skill. Now, I'm not talking like I'm a ninja. I can do all these guys. I'm just saying you've gone through that video, and you're like, yeah, that makes sense. I follow it because it's the same process. It's just going to get a little bit bigger. I'm going to add a little bit more to it. So I want to give props to our sponsor, Sonic the Real Hedgehog, which showed up at my son's baseball practice and inspired this entire idea of Petropolis. You were the administrator of Petropolis, and in the last Class C example, you subnetted 192.168.5.0 into at least five individual subnets that could be used to address each one of the stores. By the way, that was one of the things, as soon as I finished, I was like, did they really figure out how many total subnets they get? I forgot to show you that. I'll show you that right now. You're going to learn how to figure out that number as we do this, because guess what? You just got promoted. You did so well in that example that you're now the network architect for Petropolis, and they've said, we want you to address not just a couple stores, we want you to address the entire region. Notice we're now looking at all the Phoenix stores and San Diego stores, Dallas, Tucson, Eugene, all these regions of stores. And they've said, okay, well, let's step back a little bit. I want you to take this Class B subnet, 172.16.0.0/16, and break that into at least 60 subnets or subnetworks. This is kind of a general progression, and I want to make sure you understand what's happening here. In large organizations like our Petropolis, in this case, there's going to be a need for a whole bunch of subnets for all these little strip mall stores that they've got, right? There's some people that will take a subnet and break it into individual stores, and then there's a bigger picture where you're like, okay, we got to address this entire region, or maybe even the world. We need an addressing scheme for our worldwide rollout of Petropolis Hedgehog stores, right? So that's where we're at right now. We're creating the subnets that we're going to give to the administrators of those regions that they'll subnet further. What do I mean by that? I mean, when you look at this, it's a Class B network. Do you guys remember how many hosts you get in one Class B network? 65,536 IP addresses in every Class B network. Way too big for that. And I can tell you just by even looking at the simple math, if I were to just, do we'll call it ugly subnetting and divide that by 60, it would still be way too many IP addresses for a given network. You can't have giant networks with tons of IP addresses that are active because you'll get too many broadcasts and it just floods the whole thing. And that's not our purpose. Our purpose is to have these little small strip mall Petropolis stores that only have a few devices in each one of them each. So what we're going to do is we're going to create the first phase, we'll say, of subnetting, right? Where we'll come up with at least 60 subnets, and then we'll give those to, we'll call it the region admin, the person you were in the previous example, and then they'll break them down further. So they'll subnet your subnet into the individual stores. Does that make sense? That's kind of what we do as we back up into these bigger and bigger examples. The good news for you is the process is exactly the same as it was. 3 steps of subnetting that we'll go through to make sure that we can do this. Step 1, convert the number of networks over to binary. Well, we know that based on my little microfiche size font over here. By the way, if you're young, microfiche, they were in libraries, little cards. Anyway, 60 subnets as a binary number. So we write our binary chart, 128, 64, 32, 16, 8, 4, 2, 1. Almost went too fast right there. So we know there's no 128s, no 64s. Oh, 32. We can take a 32. Now, I'm going to start showing you some shortcuts. And if this throws you off, don't let it. Once we figure out where that first one is, do we know how many bits it takes to get the number 60? Because remember, think about it. I'm not really after the binary number. I don't care what the binary number for 60 is. I just care how many bits it's going to take to get that. And once I know where that first one goes, I know, oh, well, it's going to take 1, 2, 3, 4, 5, 6, 6 bits. That's it. That's the story. Now, if that throws you off, don't. I mean, you can figure out. Okay, there'd be a 48. You could figure out the whole binary number, but regardless of what this is, it's still going to be 6 bits that it takes. You can't get the number 60 with any less than 6 bits. So now we move down to number 2. Reserve the bits in the mask and find your increment. Well, we're now into a class B world, the /16, right? Or 255.255.00, which we take and break into all binary. I'm going to write that out. 1, 2, 3, 4, 5, 6, 7, 8. Dot. 1, 2, 3, 4, 5, 6, 7, 8. Dot. 1, 2, 3, 4, 5, 6, 7, 8. Now, I want to make sure that you know. Don't shortcut that part. I know you're going to get. Let me just give you a vision of the future. You're going to get so good at this and do so many of these that you're just going to be able to look at it and you'll go, got it. I mean, really, I know you're like, no, wait. You're going to do that. You're going to be that good. You're going to be that quick. Because if you think about it, again, we get back to the fact there's only 8 values that it could be, right? It's an 8-bit process in the IP version 4 world. And we have a mission here. We have this many network bits and this many host bits. And essentially what we're saying is, I'm going to sacrifice some of the hosts. I don't need 65,536 hosts on a given network. I want to sacrifice some of those and turned it into more networks. Because right now I only have one network, 172.16.0.0. I'm taking extra time to explain this to make sure that you're following the concept of what you're doing. And I'm going to say, I want more. Matter of fact, I need at least 60. So I'm going to take 1, 2, 3, 4, 5, 6 bits and flip them over to the network side. The rest of these remain 0. Now, common mistake a lot of new people in the network subnetting world make is they'll put their ones right here because they get so used to Class C. No. You pick up right where the ones leave off in your Class B world and keep extending them. That's the right way. And boom, right there, we know what our subnet mask is going to be. This is our new subnet mask, 255.255. Okay, we got to convert that to decimal. Now, shortcut guy back on the scenes. There's a couple ways you could do that. One is by adding up all the ones, right? So that'd be 128, 64, 32. And I know some of you are like, I know where you're going with this. You could add them all up, right? But we also know that the biggest number we could get is 255. And last I checked, it was a lot easier math to subtract what I don't have in this case, which is a 2 and a 1 from 255 and go, oh, okay, so it's 252, right? Because that's, again, I'm throwing shortcuts out there to speed you up. If it throws you off, don't do it. So we've got 252.0. That's our subnet mask. Or if we were to convert that to CIDR notation, again, it's the number of ones in the header. We know that, a number of ones in the subnet mask, I should say. We know a Class C is /24, and we know that we don't have 2 of them, so it would be a /22. Or you could add all those ones up, whatever the case is. Cool. That's it. We're good. We're down to step number 3. Use the increment to generate your network ranges. This is where a little trick comes in. And I'm not going to say a trick like, didn't see that coming. It's just different from our Class C, right? We look at what our increment is, which again is our lowest network bit converted back to a decimal number. This is a 4. Now, again, common new mistake. When you're first subnetting, you're like, okay, 1, 2, 4, and you get to 128. You're like, okay, that must be 256. No. Every octet is a new set of increments. So again, once you cross over, start from 1, 2, 4, right? That's your increment for this process. Okay, now we go right here, 172.16.0.0. That is what we were given, or we chose as the network architect to subnet into multiple subnets. And now we do the same thing as before. It's just, what octet are we in? If this is octet 1, 2, 3, 4, we're in the 3rd octet, right? So that's where we do our math. 172.16.4.0. 172.16.8.0.12.0. You get where I'm going with this. We could fill a whole screen with these kind of things. Now, this is where the trick comes in. What is the last IP address before you get to 172.16.4.0? Don't make the mistake. Don't do it. It's not 3.0. That's not it. Not it. Because let me ask you this. Where does 172.16.3.50 fit in? I mean, if this one ends at 3.0 and this one starts at 4.0, we just lost a whole chunk of addresses. Everything started with one. So no. So you see where I'm going, right? The last real possible IP addresses before I get to here is 3.255, right? Tricky. Through 7.255. Are you following? I'm telling you, once you've got that, you've got it. I mean, that's the only difference between Class C and Class B is that little trick right there. This goes through 11.255. This goes through 15.250. You get the idea, right? You just keep going down and down and down. And these are your ranges. Now, if you wanted to, and I know that's not the scenario, but you could assign these. I would say it's probably past reasonable, but I've seen it done. You could use that many addresses on a given network. Meaning, so there's a question. How many addresses is that? Let me show you how to figure that out. And I'll go back to the question that I asked at the very beginning. I mean, we needed 60. Did I achieve my goal? Did I get at least 60? I mean, how many total did I get? That's where a little formula comes in very handy. 2 to the power of, a lot of people will say x. Because x gets confusing because it could be one of two things. So 2 to the power of stuff, right? What is stuff? Stuff is how many subnet bits or how many host bits. If you want to know how many subnets do I really get, well, then you just do 2 to the power of how many subnet bits do you have? 6, right? And that will give you how many subnets you have. Now, I know, we're like, oh yeah, 2 to the power of 6. That's like, you can't do that in your head. First off, if you don't have access to a calculator, know that these are the powers of 2. And just make sure you remember that the first one is 2 to the power of 0. So you've got 1, 2, 3, 4, 5, 6, right? 64. So 2 to the power of 6 is actually 64. So that tells us, okay, this gives us 64 subnetworks. That's at least 60. Now, will you ever nail it like right on? You could. I mean, you've got an 8 out of 255 chance, right? But you're always going to get just a little more when you do these, right? So what about the number of, how many hosts do I really get? That's going to be 2 to the power of what? 8, 9, 10. Now, again, if you don't have a calculator, you would just keep multiplying by 2 until you reach 10. But in this case, we do. I just opened the Windows calculator. I'm going to flip it over to scientific mode. And you see this x caret y. So I'm going to do 2 to the power of 10. Hit enter. And I get 1,024. For me, that's just a few too many for my comfort. Once you reach a network size of about 500, I'm like, cap it. And that's fairly new. That's in recent years. And in the old days, before BYOD hit, you would cap it at about, that's why Class C subnet mask became so promiscuous, but so prevalent, is because you would usually 200 IP addresses. You're like, okay, that's big enough. The only thing I'll mention on that formula is don't forget to subtract 2. Why do you think you do that? Well, remember, first, last IP address you can't use. Ooh, and this also, hang on, let me just erase some of this so I can get a little more room. You guys remember all this, right? So inside of this range, let me ask you this. You're going to run into, I don't know why I'd get such kicks out of this. You're going to run into the IP address 172.16.2.0, right? It's going to be it's part of that range. Can you assign that to a computer? Think about that. Could I actually, would it take it? Would it give me an error? Let me go one step further. What about 172.16. Let's just say 0.255? Blech. Could I assign that to a computer? Would it take it? It would. As long as you combined it with that subnet mask, because again, remember, the subnet mask is what educates the network what's in my network and what's out of my network. These, we're so decimal polarized, right? We're so used to seeing 0 and 255. We're like, bad, broadcast. No. There's only one broadcast. You can't assign 3.255, nor can you assign 0.0 or 4.0 or 8.0. You can't assign those, but everything in there, it's like an Oreo cookie. You know, when you take the end in that squishy, gooey white goodness, that's what that is. In the middle is all of that goodness, and they can all be assigned to computers and devices and whatever you've got, as long as you have that subnet mask partnered with it. Man, that's good. I hope you're starting to get that feel that, okay. I'm not saying you're like, I'm awesome, I can do this with my eyes closed. You've only seen 2 examples, one Class C, Class B. I'm going to show you a Class A in the next video, and then we're just going to do practice, right? And really solidify and hone this in. Cool? For now, I hope this has been informative for you, and I'd like to thank you for viewing.